Alright, great. So after the initial connection problems are now being resolved thanks to Apple TV. Welcome back to CS6 Practical System Skills. As always, a new week starts. That means many more cool Bash terminal skills to learn. And so what did we... Oh, first let's talk about logistics. First of all, my office hours will be by appointment only from now onwards. That means if you need to chat about something, just send me an email and we'll find a date and time to chat. Second, there is no lecture on the 8th of October, which is next week, Tuesday. And the next logistical announcement is we have a midterm coming up in, exactly 3 weeks. So just so you're aware, and as we discussed in the first lecture, you can have like a cheat sheet where you can write whatever you want. That will happen then instead of the lecture on that date. Cool, all right, so what did we learn last lecture? Well, last lecture was all about like processes, how to deal with processes, how they were created. So we first talked a little about like what a foreground process is, what background processes are, how processes are actually created, and there were like these two mechanisms like fork and exec. And so when we fork, we basically kind of make a copy in memory of the process, and then usually the child process that we create then executes like an exec command to get substituted with whatever command it should be. Or the other opportunity is we can just run directly exec, which like substitutes our currently running process with like another process, which is then basically just loaded from disk. Then we spent like some time talking about how we can communicate with processes, specifically how we can send signals to them via the kill command. And we also spent some time on how we can archive and compress files using like the tape archiver utility tar, and then pipe it through like diverse compression tools like gzip, bzip2, and so on. And of course, that always brings us to a small recap quiz. And so here we have like an angry Tux user, and he says the following: I never quit programs. I always kill them using kill -9. Which is like the command for sending a signal. And so I would just ask you to discuss maybe a little amongst you, is that a good practice? What would you do instead for a minute? And what the solution to that is?
Bad practice. What's better practice? Just like trying to control. Is it like another one? And the last, like, worst case is like just use for control, which is send this out. Okay. The reason why you don't want to do this because you're basically flexing it for the running version for that. If you like get around, they might like go to like normal exit processes.
All right, great. So let's collect some solutions. All right, so first of all, who thinks this is a good practice to do? No one? Who thinks it's a bad practice? Everybody? Okay, great. So why is this a bad practice? Like, what's the answer to that? Or what should you do instead if you want to quit a program? Any ideas? Yeah.
It's a bad practice in the sense that you interrupt the program so you can lose work.
Yeah.
Finish. Or
exactly.
mess up the database.
Yeah. So what happens when you issue like a kill command? What does that basically do to your process?
Forces it to stop.
Yeah. So what it does, it basically just forces it. It kind of kicks it out of the process table. It's not getting executed anymore. And the thing where this is kind of bad is like you don't give the program any chance to perform any cleanup actions or like catch actions for the signals, because you can't catch a kill signal. And so that's kind of a bad idea if you have, for example, a database running, right? And let's say you want to quit this database process, but it still has to write log files because that could lead like to data corruption, and then your whole system might be screwed up. So you should not kill a program. However, there's like some type of process where it's like fine to kill it, and that's like if you have a zombie process, like something that's not executing anymore, and it's just like somewhere existing in an environment without doing any good work. So then you can kind of use that as like the ultimate signal to quit a program. So what should you do instead in order to like quit a process? What's a better practice? Any ideas?
Wait 3.
Yeah.
Wait, and then -3.
Yeah, that might be one option. So the answer to that is like you have like kind of a chain of signals that you can send, right? You should probably start with like something that's not really a quit terminate signal, like an interruption signal, which you can send using either like the kill command or like Ctrl+C. Then you can also send like this end of file to kind of stop input if you have like an input processing command, which you do with like Ctrl+D. Then you can send like the sig term to like terminate the program, like kind of asking nicely, please terminate. If that doesn't work, you can then send like a quit signal using like, again, kill, for example. And if all of this doesn't work, then you can ultimately use like kill -9. But like the trick is you basically shouldn't do this like per default. All right, great. This brings us to today's topic, which is string processing. And so, as always, there are a lot of cool things you can do in Bash for string processing. So let's start with the basics. Well, we already had like a lot on like kind of Bash parameter expansion, and the good news, there's even more to it. And that is like when we want to deal with like strings. So the first part is going to talk about a little advanced parameter expansion when it comes to strings. So basics first, we kind of have like here a new cool notion. It's just like we have $, then the curly braces, and like then the £sign with like some variable. And what this does is nothing else than gets us like the length of like a string variable. So how could we use that? We already learned like in another class kind of syntax how we could extract from like arrays like sub-arrays and so on, like slices. And the same thing also works for strings. So we basically just take like the colon where we can specify an offset to do like a substring operation. And we can also give it a length if you want to have like a substring of like a certain length. And so how we could use that, just have like here some small example where you basically define like our string to be equal to C-line. Then we kind of loop through, and like here the first thing to notice is that strings are like 0 indexed. And then we can basically output like a substring starting at like a 0 indexed offset. And so here we kind of have this nice triangle form of like C-line where basically just the substrings get taken from it. There's like...
So normally the hash, the £sign means comment, but over here it doesn't.
Yes, like here it has a different meaning. And that is like because it's inside the curly braces, right? And so the trick is basically how you can think of it as like that kind of when we go one slide back to like slide number 6. I mean, the £sign is usually like for the number of occurrences or so used, right? And so this is like kind of the easy way to remember that if you use it in like this brace expansion mechanism, then this basically will mean it's the number of characters, so it's the length of the string. All right, then let's go to like some more advanced topics, and that is substring removal. And so what Bash basically provides is there's like kind of 4 ways how we can remove a substring from a string. And how it works is basically we have like a string which is like here called haystack, and then we give it like a needle, and then depending how we kind of specify the operation to be executed before the needle using like a $sign, a double $sign, or like the percentage sign, it does like a match of the needle either from the front or the back from the haystack. And so how we can kind of remember that is like if we have just like kind of the $sign, we do have like kind of a shortest match from the start, which means we basically match the shortest prefix according to needle, and that gets removed. Or if we take like the double pound sign, then we have the longest prefix match, which gets removed from the string. And the same also works like from the back. So here we kind of have like the percent or like the double percent for that. And you can easily remember that. If it's just one, it's like the shortest match. And if it's a double, then it's basically the longest match. And so why is this now cool? Well, the cool thing is that we are not restricted with the needle to just use like normal characters, but instead we can use the whole Unix wildcard expressions to kind of match against the string and then remove like a matching prefix or suffix. And so in order to illustrate why this is useful, I have here like kind of 4 basic standard cases where substring removal is usually used in Bash. So let's walk a little through this. Right, so the first use case is like we want to get the file extension of a file. There's a couple of things to kind of think about, and that's like you can also have like files which have basically sort of 2 or 3 file extensions, right? Where we have like here like .tar.gc. And so in order to kind of get like the full file extension, what we need to do is we basically start from the beginning and then we proceed until we find like the dot, right? And then we remove the substring and that gives us like the file extension. Right. However, there's like some caveat. What's like the problem with that solution? How does this fail? Problem is, what about if we have like a hidden folder file / in our path, right? Then this doesn't work. However, I mean, I still include it here because often you just don't have the special case and you want like a quick and fast solution to get like the file extension. So this is like kind of the way how this works. So matching wise, how does it work? Well, we have basically our needle is like star and dot, right? And so with the pound says we match from the start and we match like the shortest prefix. So that means like we kind of go on and then we find like our first dot and then we stop because it's like the shortest prefix. All right, let's go on to another example where we have now here longest matching prefix. And that's like if we want to get the base name of our path. And we remember, like basically, I mean, we have the path always separated by like the slash, right? And so how we can do this is like pretty much the same. We take again like a star and like here a slash. And so we start from the beginning, right? And now we have, instead of the shortest prefix in matching, which would like kind of stop here, right? Because like nothing gets matched, and then we have like first slash, so it would stop if we just did like a single pound sign. But because we have a double, we kind of go for the longest prefix matching, and we see this would like go like all the way till here. And so this is like a way how we could quickly get like the base name of a path. Then there is another one which gives us the parent path, and that's, for example, useful if you want to know, like, yeah, what's the parent, and for example, listing contents of the parents also on, like seeing what the structure is. And here we basically use like shortest suffix matching. So again, same logic, right? We have the star, it matches, and then it goes like till like kind of the slash, and then we can use that because like that would get removed, right? To have like our parent path.
What do you mean by parent path here?
So by parent path, what I mean is basically when you are here, right? You have like current working directory, and your parent would be then like kind of one directory up. So I do cd dot, right? And then this would be just home. So this would be like the parent. And I mean,
So how are you getting that?
from
Originally, I thought you would be getting the file.txt.
Or you're deleting the green.
it's substring removal, so the green part gets deleted. So that's kind of the trick. I mean, we can also basically try that, right? Like we could do something like, let's say we want to save that. Let's go first in the home directory back, right? We could do something like file path is the same as like print working directory, right? So now if I echo that, then I would get this, right? And now I can do the same, but just like using basically the removal. So I use that. Then I do like kind of the shortest suffix matching for the parent. I use like slash and then a star. and now I get home as the result, which is like
What
my
indicates
parent
that
path.
it's removal?
So, I mean, what this does is like it matches from the back, right? So it starts,
Because of the percent.
yes. And so it would like kind of go on, right? And then it sees like the slash, right? So kind of the needle is exhausted. And because it's like the shortest match, it wouldn't like try further, but like it would just stop here.
So whenever you're matching from the back, you're removing.
I mean, so the general mechanism of like kind of the pound and like the percent here is substring removal always. But you specify if you start like from the front or from the back, matching like your needle against the string. Okay, another question was here.
Yeah, why did we get a homework like on this before learning?
Sorry, what?
Like this is on our homework. Why didn't we learn this before?
Oh, is it? Okay, that's interesting.
We did like 10 times already.
Yeah, well, because probably sometimes it's also cool to explore some stuff first, and then like have a little challenge, and then the lecture comes and it's all like, oh, I know this already, perfect. I can lean back for 5 minutes on a Tuesday afternoon, which is also not bad. But yeah, of course that shouldn't happen, so sorry about that. I'll talk to my TAs about that. All right, so just short question. So we all know about substring removal already?
Well, like partially, yeah, it's on the homework.
Oh, okay, great. Well, then I don't have to go in detail over it, right?
No, you should.
We think we should.
We should? Okay, so let's go over detail on it, okay? Alright, so we have like these kind of 3 examples, right? Where we had like kind of file extension, base name, and parent. And then there is like one more trick which we can do, and that is like we can basically remove the file extension. It's always the same logic, right? So here you kind of want to remove all the file extensions which are like kind of done with the dots. Again, you have to be careful with like hidden paths and so on. But if we just have like regular files, everything fine, we can use here the same logic, and we kind of greedily again do like the same, like, you know, the star matches, and then this time we just go like for the longest matching suffix. And that's like one way to kind of remove that. And why is that kind of useful? Well, sometimes you basically just want to rename files with their file extensions. So this is one cool trick, how you can quickly kind of remove them and then kind of transform your paths to like some adequate way. Or you may want to like whatever, sort folders and so on. So it's just one more tool to kind of get in the whole toolbox of how to do cool string processing. Alright, that brings us to the next cool thing you could do, and that is like you can do substitution. And so how this works is kind of, again, pretty straightforward syntax. We first have like our string where you want to substitute something, we give it a pattern, and then the string what we want to replace the pattern. And the way this works is kind of a little interesting on the first side, and that's like it basically replaces the first occurrence of the longest match. So it's not like many other replace algorithms where it's like either like the shortest match get replaced or all matches are get replaced. It's just really the first occurrence of the largest match that gets replaced. So how does it work? So let's say we have here like one example, right? We have another path. It's basically a path file.tar.gc in Tux's home directory. And let's say we want to just like kind of update this path to now belong to C-line. What we can do is we can just like replace tux with C-line, and then we get like kind of this updated path. And why is this cool? Well, we could use it, for example, to kind of quickly clone directory, manipulate strings again, and so on. There's like here some more examples on how to use it. So again, the whole substring substitution only replaces the first occurrence, and we can also give it like a little manipulation by again using like a pound sign or percentage to say where we want to do like the matching, either like from the front or from the back. So let's walk through it. Well, we have here kind of the first example, right? Here we replace basically ABC with the X, Y, C. And so how this works is it basically starts from the beginning, looks for the first occurrence, and then replaces it. If we now add like a pound sign, something interesting happens, and that is nothing gets replaced. Well, why is that the case? Well, because like unlike before, we explicitly said please match from the start of the string. So that means here actually the first character is a slash, and so this doesn't match like ABC, so it stops and it doesn't get replaced. And however, if we do like, for example, the whole thing like with a percent, right? We don't have like a slash here. And the interesting thing is like, I mean, the direction doesn't get reversed, right? I mean, it still kind of matches the whole thing and just slides it to the left. And here then basically ABC gets replaced with XYZ. And so if we want to fix like kind of the example where we have like the matching from the start, we can do so. If we basically just want to replace like slash ABC with like XYZ. And so how this works is basically we just need to escape it, and then it works. Yeah, there should be actually like here another escape sign. Sorry about that. All right, let's have some more practical example of what we can do with that. And that is like we can rename files. And so this is like kind of one example really of the practical toolbox that I usually use like on, let's say, a weekly basis or so. And that is like if you have like, for example, HTML files or JPEG files or so, they have like kind of this odd behavior that their extension is not standardized. Like some websites use .htm, some use .html, and the same goes like for JPEG, right? Some just like .jpeg, some just has the e in it or not. And so with like substring substitution, you can basically just clean up that mess in your folder pretty easily. Because what you could do is you just start like a simple for loop, right? Get like all the files matching that. And then you just normalize it by replacing the extension accordingly. And I mean, that's just like one neat tool which you can use to quickly kind of replace extensions in as many files as you want. All right, we have some more tools, which is like we can do case conversions in Bash. So how does that work? Well, we have like kind of the caret symbol, which converts the string to uppercase. If we use a double, it's like every character gets converted. If you just use a single one, it's only for the first. And the same also works like with like kind of the comma for like lowercase. And again, the same logic, like if we have a double, it's like everything gets converted. If we just have a single comma, it's only the first character that gets converted. Speaking of some examples, here just put like some string of like hello world. Now we can kind of convert it to uppercase, can convert it just like the first letter, lowercase, and so on. And so this is like kind of one manipulation that comes in handy if you just write your scripts and quickly want to have like some formatting done on them. Alright, so that was like just like some more stuff on like brace expansion. As always, this is like kind of the things you want to use either like very quickly when you write directly in the terminal or when you write scripts. But in order to write like some more powerful text processing commands, what we need are more commands. And so as always, it's a piped world, meaning we have like many commands, we can combine them like Legos together and build awesome pipes with them. So let's talk about that. And that is like working with text files. So how does it work in general? Again, we have many commands, we give them some options, they manipulate our text files, then we combine them using the pipe operator. And when we talk about text files, what we really mean is always like, it's like nicely formatted into like multiple lines separated by a new line character and made up of words which are separated by a white space. And the white space can be like something like, for example, a tab character or like really just the white space character. And usually all these commands also provide options to kind of specify how to treat white space, what counts as white space, and so on, so we can kind of manipulate them. And because when we usually start with a text file and process it, it gets like less and less lines, or sometimes also more lines. There's kind of this, yeah, not very accurate notion, but notion nevertheless that like many of these commands are therefore called like filters. So basically you start with like some command and then you say like, yeah, let's apply a couple filters to it. But what you essentially mean is just you process them through using the pipe operator through like additional commands. Right, so let's start with like a first filter / command, and that's word count. And what does word count do? Well, word count basically counts the words. There's a couple options that we can use, like kind of -L to say we want to count lines, -M if we want to count characters, or minus W if we want to count words. And so, because it's always practical, let's make some example. So we can open a file, right? File.txt. We can write something like Tux loves seafood, especially squid. Sea lion loves penguins, but would never eat Tux or something like that, right? Okay, so again, we can just cut it, right? And now what we want to do is we basically want to count the words. So easiest option is we kind of just execute the command purely on the file, and what we get is like kind of this line where we have like 3, 13, 86 on that file.txt. So what does it mean? Well, 3 is basically referring to the lines, 13 is the word, and 86 is the number of characters we do have. We can also like just get like the number of lines out if we use -l. We can also get just the number of words if we use -w. And what we still have is like kind of this odd thing, the notion that like file.txt is mentioned. And as I said, the cool thing is always we can build pipes. So let's build a pipe, and that can be done by, for example, using cat file.txt, and then we use like word count, and this kind of solves the problem of us that we do have so like file.txt, because then kind of word count acts as like a true filter and only gives us the number of lines.
When it gives the number of characters, does that include spaces?
I think it should, but we can make a test. So let's make a test.txt. Let's do A, B, C, right? So if it includes that, yeah, it does. So
There weren't even 6 characters in the file.
no, that's not true, because there is, yeah. I think that's like actually there's an end of file character that counts. Like we have 1, 2, 3, 4, 5, and then end of line is the 6th character. So that's why we get, but it's like also the size of the file on like the disk in that case. All right, cool. There's also like one more example that's kind of widely spread when it comes to word count, and that is like basically what usually is done in lectures, like the intro to piping example. That's like if you have something like list, right? You can also like just pipe that to word count, and then if you do like words on that port, you basically get the number of files in your directory, which is like just one cool application of how you can use word count together like with other bash commands. And I mean, of course, the same goes if you have like something like processes, right? You can also use like word count -l in order to get like the number of running processes at this moment. Yeah.
Wait for the top one where you do the ls and then you pipe this a word count. You also do flag -l.
Yeah, of course. You just have to kind of adjust your word count program, right? So if I do -l, this gives me this, right? So if I now use like words, I would get 29.
Oh no,
But-
sorry, you just did ls pipe wc -l.
Oh yeah, that works too, yeah.
Okay.
Because list per default, I mean, if you don't give it a parameter, right, it just lists the current working directory. Yeah, so it works too, yes. But yeah, as I said, like if you have like -l, for example, you want to adjust like if you count words or lines, so you always want to make that distinction. And yeah, all right. And as always, I mean, we talked about this in the first lecture. There's kind of the two options to have like either a short option or a long option. And so many of these kind of text processing commands also have like this opportunity where you can select if you want to have like kind of the long version or the short version, which might be sometimes like handy. Right, yeah, here I just include like a couple more examples. Basically, yeah, it's pretty much what I all demonstrated. You can pipe files and so on, and then get like the numbers. And the only interesting takeaway here is that you basically have this behavior change in like when you put like the files, it kind of prints the number and then the file name, and also just prints like the raw number. And if you don't specify like an option or many options, it still like kind of puts the output in like columns separated. All right, yeah. here, just like the examples using lists, so you can use that to count files. As always, you can use the whole Unix wildcard expressions to kind of narrow what files you want to print, which is kind of cool if you want to quickly count how many files you have in a directory. And yeah, depending what the command output is, like lines and words might be actually the same result, like here. Alright, as always, there are more tools. So let's jump to the next tool, which is unique. And so unique is now like a very interesting tool, because what this tool basically does is like when you have a file with like lines, it starts at the beginning, walks through, and then it reports of like a block of adjacent lines, whether they're the same, like a duplicate or not, and you can give it like different options, what to report and how to report. And so the basic option here is like a -c, which is like for count, and so this basically will report like the count of like the adjacent matching lines. Then you have like kind of all these flags like -d, for example, if you want to just print like duplicate lines, or like large D if you want to print like all lines, and then also like -u if you want to print only like unique lines, so those which have not like a duplicate coming. So how does it work in practice? Well, I have here like a sample, right? And let's see how it works. So we can basically start with like -d, which would just print like groups with like duplicates. So it's always like kind of unique starts at the beginning, right? So it scans here, sees, okay, this is Apple, right? And it comes a new line, which is again Apple, so this is duplicate. So it would print this out, right? Then it goes to Peach, right? No duplicate, so nothing gets printed. Apple, again, no duplicate, so nothing gets printed. Same for like banana mango, and then we go to cherry. So cherry, we have like here kind of two lines which are the same, so cherry would get printed here. And so what this command would basically yield is like a list of like all lines which have duplicates in the file. Then we have like another one where you have like here the count of like duplicates. So what this does is basically, okay, starts again from the top, right? We have 2 times apple, 1 times peach, and so on, then 2 times cherry. And so it would just like prefix basically the line with like the number of occurrences in like an adjacent group. Then we have like these 2 more options using like -u and like -d. So -u is basically the complement of -d, right? So here it wouldn't print apple because it has duplicates, but peach and so on because they don't have like adjacent duplicates. And then we have like kind of the variation of like -d, which is like -D. And so what that does is like it also just prints like kind of the lines which have duplicates, but it also prints it as often as there are like duplicates in the file. And so as always, it's a toolbox, and it always just depends what you want to do with that. So what can we do with that? Well, in order to really kind of leverage that, we need another tool, and that is sort. And so what sort does, it basically sorts the lines. And again, there are like a couple options. We have -r to reverse it. We have -f to ignore case. And then there is one interesting one that's -n. That is like when we have numbers, they still would get per default sorted like strings. And so what that means is basically, if I have this example here, right, 34, 2, 65, 200, and so on, okay, I go through that, and then I see, okay, everything fine to like 2, and then 200, 34, well, that's not in order. That is because it's basically interpreted as like a lexical sort and not like a numeric sort. And in order to fix that, you would just have to give it like the additional option -n, and then the whole sorting with numbers works too, which is like kind of one tiny thing to keep in mind when using sort. Alright, so let's see how we can kind of use that. That is like, let's say we want to count the number of words in a document, but this time not like the total number, but rather the number based on like the word itself. That means like how often does one word appear in the document. And so what we can do here is we can use both commands together. First, we sort the file. So we basically have like here now everything like in one adjacent group. Then we do like one scan over this like using unique. and then we get like kind of the result, and we see like that Apple actually appears 4 times in this document. And so this can be like useful if you want to quickly get like whatever a duplicate count or so. And so the other interesting bit about this is like maybe it's a quick poll, like who actually did ever take a database class or work with databases? Okay, 1 person. Yeah, so for those, this principle is basically what's actually underlying like a sort merge join or sort merge aggregate in a database. It's the same principle, just here in Bash. All right, let's also maybe demonstrate this quickly, how this works. So we can make a list.
This underlies databases, or this is using a database to do that?
No, that's just like the same principle on how you can make an aggregate quickly. You can basically sort the data and then go in one pass over to have like adjacent group and count them. That's like how you could implement an aggregate. All right, so let's say we have here a file lists, and then we kind of give it like a couple things. Right. Now we can kind of cut it. Then we can sort the whole thing. And then we just pass it through unique -c, and then we get like here all counts back. As said, pretty cool tool if you want to quickly count things. Yeah.
Oh, why do we use type instead of like re-standard output?
I mean, as always, we can use the tools, right? So what we could do is also we could do something like sort list.txt, and then we redacted the standard out to a file. So let's say this is now our temporary out, right? And then we could use unique -c to either work directly on the temporary out, which would give the same result, or we could basically pass it in, right? Same result. Or we just have a wonderful one-liner in Bash, which basically does the same what I just did
So you can't
using the pipe operator.
You can redirect standard output into
I mean, that's basically what the pipe operator does, right? So the pipe operator basically connects the standard output, and I think also like standard error sometimes, depending if you configure it like redirection correctly, to the standard in of the next command. And so you're basically safe to kind of have a temporary file where you first write stuff to and then read it from. That's the cool thing, and everything happens like in main memory, so that's why it's like very fast. All right, cool. So then let's move on and have some more tools. Here we have format. And so format is like one of these kind of historic tools which were used when you were really writing a novel in a terminal. Unfortunately, I never read one of these terminal novels, but I'm sure they exist. And so what this does is basically, if you have your characters in your file, you want to justify them, meaning you want to have like each line have a specified width and characters. And of course, if that doesn't work out, then you have like some overlap. And format is exactly the command to do that. So, for example, if we have here our file, I think it was file, right? Yeah. Right, this is our novel, and let's say we want to format this nicely. So each column should be at most, let's say, 16 characters or so. Right, then we could use that using like format, and then we see it basically would break the lines according to the character count we gave it, right? If you want to have like longer lines, like let's say 25, right, then it's kind of a different story. And why is this useful? Well, you always have to see like your terminal has basically this character count, right? So you want to kind of break your lines across, and format is one tool which you can do that.
So there are 25 characters per line there?
Yes, or more.
Especially Squid should all be on one line. Like, why does it break it up there?
That's a good
What
question.
was your original file? Is it all still breaking up by the
All right,
the line
so
breaks of the original file?
how it works is like so it basically, I mean, I don't know what the default option of it is, but if you basically give it this, I mean, it has some algorithm, and it would basically like if there's overlap, right, it will have to compensate for that somehow. So I guess that's like what it does underlying of it. But as I said, the details should be like in the manual for that. And the key takeaway from this is not like how to do the most fancy formatting, because there are better solutions than the format command around, but rather what it really does is like it splits up your text into like different lines. And for us, how we want to use that is we basically want to use it to split a file into words. And how we can use that is like if we just use like -1, would split it into words. So again, let's do like -1 file.txt. And here we have now like everything split in words, because you basically just allow one character and then would break like everything down. And so, I mean, looking at the 25 case, I would say, what was it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So basically especially doesn't fit. So especially would get into like the next line. So that's like how it would break off. And then I guess the algorithm would start over at the next line. So that's why kind of there's like this weird jump after like, especially where it's like kind of not compensated anymore. So that's basically how it works. Yeah.
Was there like a new line after especially, or?
There was, yes. So that could be like also like kind of the reason for that, yeah. Okay, cool. So now we know how to split everything into words. And then we have like kind of another cool tool which we can use, and that's called Translate. Again, this is also like one I just want to mention like shortly. There are like many more options and like kind of the man page is available for this tool. But what this does is this can be used to kind of replace characters or substitute characters on like a character-to-character basis. And one easy use case for it is like we basically want to strip a string of white space, and how we do that is like we basically do like -d and then pass it here as class, the character class, and this basically would remove white space from our lines. And again, we can use that to basically tune our words a little more. So let's see how this works on a concrete example. So here I want to make like one more advanced kind of query over like some larger text. So here I basically have a copy of Hamlet as a TXT file. That thingy is also online, so we can basically start by curling it down. So this is like https, then we go cs.brown.edu /cs. Then courses cs0060 assets hamlet.txt. So there's no typo in it. Alright, and then it would download just a terminal Hamlet novel from Shakespeare. And then I can kind of do the first command, and that is like I can just like split it into words. So I use that. And then we kind of see here there's like still this white space. So I want to feed it into like the translate command to just strip it of like the white space at the start and end. So I would use that. So now I have like all my words nicely formatted there. Then again, I want to use kind of the sort unique logic to aggregate the word counts quickly. So again, I first sort them. So now I have like all the words sorted. So see, okay, my kind of approach is not perfect because there are like some special characters, so I might want to kind of get rid of them too. So again, I could run something like translate -d and then just give it like a special character, right? So this would get rid of the comma. I mean, I can pipe a couple more if I wanted to. So I can do like this, right? And I can also like get rid of like the minus. So here I got rid of a lot more. And then again, what I do is like now I want to kind of count. So I use like a unique tool to get like the counts of like all the words. So here I have now all the counts. This is like, again, a lot of output. So I kind of want to limit this. So I could use something like head -5, right, to just get like kind of the first things. That also doesn't look that great, and I actually want like the top 5. So what I need to do again is like kind of just sort it using like sort -nr. So here it's now sorted, but again the output is pretty large, right? So yes, according to that, it's not practical. So again, I can just like use head minus n5, and then I get like the top words, and I see actually the highlights of Shakespeare is end of to and above all I. So this is like what Hamlet is all about. All right.
What was the end flag for the head?
That's the number of lines you want to return. So if you have like file rate, you could do like head -1 shortly to return the first line, or you could do like minus n1. So it's like the whole trick. Same goes, by the way, if you have like the super long thingy, right? You could also just use tail to get like the words which are like the least frequent. And I mean, that's just like one way to kind of quickly get like some counter to just demonstrate that you actually can do a lot of string processing in Bash very quickly if your data is nicely formatted enough. Great. Speaking of that, let's do a short break of like 3 minutes before we talk about columnar files. So we will continue in 3 minutes on 4:53. So that depends what options you pass it. So if you just pass it nothing, it will just print the output to like standard out, which is kind of cool, right? Because you can quickly pipe the website or a content of a website or a file or whatever to like one of the other bash commands. However, if you want to just file it, you can save it like -O or -O, depending how you want to store it. Yeah.
So it's like, let's say we wanted to save download one of the lectures.
Yeah.
Just curl it with the O.
For example, yeah.
And then just like store it somewhere.
Yep, that's what you can do. Which is pretty straightforward. Yeah, there's also actually an example coming up, I think, in the lecture slides pretty soon, like how to do that very quickly. Yeah. And like you also have to think of always like you can actually do some really, really cool stuff. Like for example, if you curl a website, you could just feed it into a compression program and like compress the stuff out to a file, which can come in handy too. Like, I mean, example would be, let's say you want to download some large video file or so, right? And you directly compress it, just use curl, feed it through like a pipe through like gzip, and then save it on some file, for example. And then you have directly a compressed copy.
Wait, what's that? Like how much smaller is that compressed copy?
It can be smaller, it depends on the video file, right? And your compression algorithm that you select, but can work. I mean, other thing is you could also like fetch a website encoded, like you could basically use, for example, OpenSSL to encrypt it, right? It's like, you can be really creative with like these commands, which is the cool thing about it. All right, it's a 53, that means let's continue. And so the next topic I want to speak about are columnar files. And so why is this important again? Well, first of all, many commands like unique -c print output in columns. So we want to know how we can work with columns efficiently. And so there's like basically different flavors of it. And two of like the most widespread prevalent types are like CSV files and TSV files. And what does that stand for? Well, CSV is basically just comma-separated values, and TSV, analog to that, is tab-separated values. And the idea is basically you just have like your data, and it's basically each field is separated then by like a separator, which is like the comma or the tab character in this case. So here are like some examples, right? We have like 3 columns here, then we just like separate the fields using like a comma, and we can also have like something like an empty field or so, and it's just like one way to format columnar data very quickly. And so what's the issue? Well, there are a couple issues with that. First, let's talk about CSV files, and that is like, while the idea is very compelling, right? You just use a comma to separate like your values. It has like a lot of problems in practice. That is, there is actually no standard. Like for example, if you ever get like a CSV file from Excel or so, they use a different separator. You use like kind of a column. And then there's also the problem of what do you do when you have like fields that contain a comma character. What about like new line characters and so on? And so there's one kind of attempt to standardize that, which is like the RFSC -4180. And what this says is basically, so you separate rows first of all using like new line characters, nothing else. And if you have a comma or new line, you can quote the field using quotes. And if you have a quote in your quoted field, you can escape it by just using a double quote. So let's see how this looks like. Here we have like one file, and that's like kind of here. Yeah, we have like, this is a column containing quoted comment, right? So I use like double quotes to kind of quote that. Then white space in the column is fine, right? So here I basically have like some white space and so on. Then I can like kind of escape a new line using again just like quotes and so on, and then I have the data. So a CSV file can also look like that, which is rather complicated. And the thing is like, sometimes when your commands break when you work with CSV files, that's because you have such a complicated CSV file, which is like not standard compliant. And why are we talking about all of this? Well, basic reason is, I mean, we're still always like kind of looking for like practical system skills, and that is like a lot of data that gets shared, especially if you go into like all the fancy fields of today, which is like machine learning, artificial intelligence, hopefully databases and analytics. Then you have to deal with CSV data. And here the idea is like, please always be like standard compliant. And this is how you could basically create a standard compliant file, which you could actually then also parse or like give to people so they can parse it. All right, so how can we work in Bash or like such columnar files, like either easily formatted like CSV files without the quoting, or like just like the output of like Bash commands? Well, we need to have some standard utilities, and the first one is cut. And so what cut allows is to basically remove or select parts from each line, meaning effectively it can extract one or more columns and then return them. And so it works is like, first you have like the -c option, so this would just like select characters. We could also use -b, but that's like just like the difference is bytes versus characters, right? So remember we have like kind of these different string encodings. So UTF-8, for example, can be 1 to 4 bytes for like one character. With bytes, you can just like select by bytes, which might be like more helpful when you want to use like binary files. Then we have like -d, where you can specify a delimiter. So by default, cut uses like kind of tab as delimiter. And this is important when you want to use the -f option, which is used to select fields. So basically, cut would automatically kind of split a line into like fields based on some delimiter, which you might specify. And then you can use that to kind of get one column out ultimately. And when you want to specify that, you can basically use a list for that. That's just, you basically give like a couple numbers, can be also a range, comma separated, to kind of return whatever you want. And the important thing to know here is that basically the order doesn't matter. So it's like not order aware. It will always just go from left to right when it returns data. So yeah, here we have a couple examples. I would say let's try it out here in the terminal. Okay, so let's create a table. So let's say like here we have animal, then a tab to kind of separate it. Then we have like something like food, and then whatever location or so. So we have tux, whatever squid. Then okay, penguins are in the Antarctic, right? Okay, something like this. Then we have tango, also loves fish, and it's in South Africa also. And then we have sea lion, penguins, right? And sea lion lives, let's say, in California. All right. All right, cool. So we have now a simple table. So again, we can just print it out using cut. And now if we want to kind of cut that, we can, for example, just select like the first field using like -f. It always uses like tab as default separator. So if I now pass a table, it would just return me like kind of the first column. And again, piping is cool. So I could also do stuff like, you know, now tail -3 if I just want to get like tux, tango, and sea lion out of this. Then I can also use like other commands. Like for example, let's say I want to have like kind of just the second and third field here. So then I could just like specify a range here and I would get this result, right? I could also just like use a different delimiter. So I could do like something weird, like for example, using let's say O as delimiter, which makes no sense, but like still I would get like kind of some result out of it because it's really just a dumb command that executes the steps, splitting and so on. But it makes more sense if I like kind of I go into my table and let's say here I kind of want to know like just have like everything like say comma separated, right? Then what I could use basically is again just like using the whole cut logic to kind of extract the second column. So I would use F2, right, to get the second field. But now I specify like another delimiter, and then I would get like food squid out here as a result. So that's like kind of the handy tool to know if you want to deal with like data and just get like a column out. Question here.
Yeah, by default, is it splitting on white space or only on tabs?
On tab. So yeah, that says something here. Yeah, it's per default. Yeah, it's a tab per default. But you can specify like any delimiter you want, basically. Cool. All right.
Is tab defined as white space, like a certain number of white spaces, or is it a different character?
It's a different character. So if we remember like kind of the big table, like the ASCII table, like tab is just one. Yeah, one number basically in the end. That's different from white space. My question here.
Is there a way to use like head or tail to put it all but the first line or the first two lines?
I think there is. Not sure, but like what I would like reckon is like that you could use maybe negative numbers or something like that, or they might have also like kind of an option skip rows or something like that. So
I guess you could like count the number of lines.
yeah.
Just
Yeah, so yeah, I mean I didn't find it now, but like there's for sure some command existing, but as always, like it also depends a bit on your kind of operating system, what functionality the command supports, because like sometimes if you have like a Mac, you just work on a Mac, it has a couple more options, or vice versa when you work under Ubuntu or so, because like sometimes people just amended it, but like kind of for head tail, like the minimum functionality, which is usually supported across the board, is like just like, I mean, straightforward, take the first or like the last lines, and after that it's, yeah, it's like a question what to do with it. All right, yeah, there's a couple more examples here. Yeah, one very cool thing is like complement. I kind of want to show that too. And that is like, so if I do like here minus F2, I get the second field. But sometimes what I also want to do is just like get the complement, so basically all the other fields. So how this works, if like I want to get like kind of the first and the third, but not the second, I could just use like minus minus complement to kind of invert my field selection. And as always, you can also use that on like if you just want to select like the character ranges, right? So if you want to, for example, let's say we want everything after the third character, so we would just like type something like 1 minus 3, right? Oops, and then it doesn't, oh yeah, D is not working with like characters, right? But like here we basically have like everything after it that's selected, which is like one cool tool to kind of, yeah, cut basically across like character columns in a file. Right. So yeah, here again some more examples how you can use it like on a table. I mean, I would say I demonstrated most of that already, so let's skip that slide. And yeah, let's go to like one more kind of cool practical example, just here on the slide. So what I could do is like, let's say I have here like my very good formatted CSV file, no quoting or weird things going on, and I want to just like add a header to that. So how I could do that is basically I could write an echo command, right? Using like the quotes, I can kind of write free text, right? So I could like make here a break, then I do like command substitution, and then I kind of put all the result to like out.csv, and then I have like kind of just quickly added like a header to my file, which is just like one way to do it quickly. However, of course, at some point the question is this really more productive than quickly starting Vim and like just typing it on your own? So this is like always kind of the trade-off you want to do when you work in a terminal. There's a fancy way and then there's a quick and practical way. So yeah, it's always a trade-off in the end. Right, yeah, some notes on cut. So as I said, the order is ignored. So minus F1, 3 is the same as minus F3, 1. It will still print the fields in order, first field and then third field, because it always goes from left to right. Same is true for minus C. Then, yeah, some general bit of advice. If you have CSV files and you work with them, if they're nicely formatted, you may use cut, but if they're bad formatted, don't try to use cut on them. There are better tools for that. And yeah, the basic idea is like, don't go too fancy, like use it for like simple output manipulation, like when you get like output from like basic bash commands, like whatever, process status, list, and so on, to kind of extract the information you want. Like for example, if you have ls-l, right, you might want to extract the string which holds like the file access mode, so what kind of rights or permissions you have if you want to print that out nicely, right? That might be like an option where to use cut in a nice and neat way. And yeah, that's basically the use case for cut. Right, after this, we have some more fun commands. Amongst that is past. And so past does nothing else than basically merging lines of files together. So we saw how we could like kind of cut up a file, and now we want to merge it back. And so there's like a lot of options available. I think the two relevant ones are -d, where you can specify a delimiter to kind of merge lines together, and then -s, which is kind of one cool way to kind of transpose a file. Because the question is, when you merge lines, is like how to do that, right? So you could either do like one strategy, which is like you take the first line from one file, then put a delimiter, and then take a line from the other file, and then go through that. So you have like that kind of file. Or you could first take one line from one file, put a delimiter, put the second line from that file, and so on, and do the same for the other file. And what this would do is basically would create like a transposed file. So how does it look like? Well, let's say we have here like two files, countries, and yeah, the other one should be called capitals. I'll fix that typo later. You want to kind of just merge them together, so you could pass it like a delimiter, right? And then it would take like the first line from like countries, and then the first line from capitals, and then just create this neatly formatted file. And if you kind of want to transpose it, you just have to specify -s, and then it just has like the other logic where it kind of first goes through one file and then the other file. So this is like one neat way where you can quickly compose stuff together. Speaking of that, as always, there's one more cool thing in CS6, and that is process substitution. And so when we deal with all these text processing commands, they have like some shortcomings, as usual in Unix world. And when there is a shortcoming, always also somebody thought of a cool, innovative solution how to handle the shortcoming to just give us more expressive tools. And one of them is process substitution. And so what that does, it basically allows you to pass the standard out of a command like a file path to a program. And the issue why this is relevant is like, when we look at paths, we see here it needs like a file, so it doesn't accept standard out per se. But sometimes it would be cool if we could just use standard out, right? And so what we can use process substitution, which basically creates a temp file path on the fly and passes that as file to like our command. And so let's look at our not so great looking example from before, which is like how we can add a header. And so in order to improve that, what we can do is we can basically abuse cat in the following sense that when we pass cat multiple files, it will concatenate it together. So we kind of here use process substitution to just echo here product price. This would get to standard out, then it gets treated as a file path, so this would be like a temporary file. And then we have again our cut logic to cut out whatever we want from the file. And as always, the gist out of that is like you could have also used Vim to kind of just edit. So you always want to make the trade-off, how complicated should your program become. But it's like one more tool in the toolbox to achieve like a lot of cool things. Cool. With that, we can also use past for something other, and that is like we can use it to actually reorder columns. And that is like before we had like kind of the issue that well, cut didn't really notice the order of like the fields. And so for that reason, what we need to do is we kind of just cut out one, then the second, and then we can use pass to merge it back together, and now we have essentially reordered our columns to like one file if we wanted to do so. Right, last tool for today is called diff. And so what diff does is basically it compares two files. There are a lot of options in diff. The one I kind of want to share is -y. And so what -y does, it basically puts the output into columns, and then you can compare it like side by side. There's also a detailed syntax if you don't use -y, if you should add a line, change the line, delete a line, or so on, which you can use to debug quickly how kind of the files differentiate. And the kind of cool thing to know about this tool too is that, again, you can always use like the logic of like exit statuses, return codes, and so on. So for example, if you get sent a file and you want to quickly check, well, are there any updates to my local file on that? You could just run a diff command, and if this has like a non-zero status code, then there were some changes. And then you could run diff again to kind of find out what changes were made. Yeah.
So what do you normally run diff with, like, for example, with Git, where you
yes, exactly. That's what actually, yeah, that's actually the git diff command. I mean, it is diff at the end. Yeah, and that's what you do. And that's why it's also like here included, because it's relevant for especially coding purposes. Cool. So let's have some cool example on this too, combining all of it. So we have diff, and we have like always like a couple directories. We have like user, and we have user local. And let's say we want to compare the directory structure of those two. So what we can do now is we can use diff for that. We use process substitution. So we basically use like just user, and again process substitution for user local. And now we kind of have here our diff on like the directory structure, which helps us to quickly grasp how these two actually differentiate. And that's like, all right, so basically user local has like another directory, etc. Right? Then The other one has like directory local, so we have like kind of the arrows pointing to like each argument to let us quickly understand where stuff was added or belongs and so on. And then we see also that like user local actually has the man directory where like all our manuals are stored. And so this is like just one cool way how you could basically combine all of that in one command to become really productive again, like in your system. The option is, because this syntax also needs some time to get used to, is you could use -y. And, okay, what's happening here? I think this is weirdly formatted for some reason. Oh yeah, I know why. I kind of zoomed in too much, and it required more characters than could be displayed. So if we have now a little zoomed out, it looks better. So here we basically have now a different syntax, so we have the contents displayed again line by line, but this time kind of in a different fashion. And that is like, we see basically that, I mean bin is the same, right? And then, okay, on user local we have like the etc. folder. Then we have here at this point a difference, that's why there is like kind of the bar, right? We have like kind of on one side it's spelled local, on the other one is man. And then again the rest is like kind of the same. And so this is like kind of one other way to quickly compare files. And as always, that also works with like stories. So let's say I have here my story, right? I quickly want to make a copy. So let's call this file2.txt, right? Let's go into file2.txt and let's add this. Whatever, I mean, we can always delete stuff, right? Okay, okay. Right, and now we can div it again, so we have file.txt, file2, right, and we see here like kind of the differences in like the lines again, or we can use like div -y to have like kind of this easier overview where kind of the lines are separated. And you see already like kind of here's the issue that you need like kind of enough characters to display the lines, so that's like why kind of the first syntax is the default, to just have like not this line break program. All right, speaking of that, yeah, here are again a couple examples on the slides. We did most of them in the terminal anyways. We can use process substitution, for example here, when you're just like comparing the structure of like two directories. And yeah, the last command I want to talk about today is xargs. And so xargs is like now, again, one more flavor to kind of combine everything in a fancy way together. And so what this does is basically, it reads words from a file or standard in, and then passes it as parameter or arguments to some command that you can specify. And so why is this cool? Well, this is cool if you want to basically have a file with like arguments and then iterate over this file or basically loop over that to kind of execute a command with those specified arguments. And again, a couple parameters, -a to kind of specify the file from which to read. I also just use a standard in. And then with like -n maxargs, you specify how many arguments you want to pass in each run, basically. So if you like have -n2, it would always read like 2 words from the file and pass this argument and execute the command with it. So why is this relevant? Yeah, well, let's say you want to download URLs, so you want to just fetch like all the course slides. So what you can do is like, yeah, well, you can go to the website. All right, then you kind of have here the lecture slides. You can just copy the link address, right? Then let's go in here, make a file urls.txt, And then we can just copy and paste that. Then we can kind of change that, right? So now we have like slides 1, 2, 3. We could also write a loop if we wanted to. I mean, you can always develop a script, right? But if you want to use xargs, what you could do is like xargs minus a, and then you give it like the URLs file. Okay. So now we want to kind of just download them. So we use curl again for that. Then we use -o as another parameter, and then xargs would kind of feed that to the command. And so, bam. Okay. Why is this messing up? Let's check the slides. Oh yeah, of course, I forgot that I just should always pass only one URL. So sorry about that. So -n1. And now the whole thing works, and now it downloads basically the files, right? So it reads one argument from the file in each run, and then it kind of downloads all of that. And that's kind of cool if you quickly want to just like download a list of files, right? And yeah, what more to say about that? Well, that is, if we go into this, this is like kind of a cool solution, right? But it's not yet completely nice. So we need kind of more text commands to work more efficiently, so there's a bunch more. I included just a link if you really want to learn more and more about text processing. This is a good reference, but it's not expected for the midterm. I just want to say that. So it's only whatever is in the slides. And the cool thing that you can really do with like all of this, like, you know, passing commands to xargs to download and fetch files, is if you had some way to extract strings out of files in a neater way. And this is exactly what the topic of like the next lecture is, and that's like how we can use regular expressions, for example, to like get from an HTML page, which we initially curled down all the links for, let's say, all images. Then we can pass them to like xargs, and then we can pass that again to like curl, and so we can download like, let's say, all links from a website in a quick bash way. That's exactly what we're going to do next lecture. And again, homework 4 should be out today. And there's also a lab today for regular expressions, like a good introduction, so I would encourage you to attend. And I'll see you next Thursday in 2 days, 4 p.m., 5:20 here again. Thanks.